Good morning, mathematicians. It is Wednesday of week 11, and we are starting off with thinking about what expression can match the shading that we are seeing in this square. So we are tasked to write an expression. So let's go ahead and let's take a look at the rows first. Remember, we will see one of our factors in the rows and we will see one of our factors in the column. And the thing we ask ourselves is, how many rows are there in all? And then how many of those rows have shading? Well, there are 3 rows in all. So I'm going to make a 3 my denominator. And then how many of those 3 rows have some shading? And that would just be 1. So I am seeing 1/3 in the rows. Now I'm going to turn and I'm going to consider the columns. How many columns do I see? 1, 2, 3, 4, 5. I see 5 columns. And how many of those columns have some shading? Just one of those columns have the shading. So to put this together as an expression, we will take our 1/3, we will take our 1/5, and we will multiply those together. Notice, boys and girls, it says expression, not equation. So I don't actually have to have the equal sign and 1/15 as my answer. I just need the two factors being multiplied together. Okay, we are ready for some irregular volume. And I see irregular volume here because I'm seeing a prism here, a prism in the middle, and a prism on the bottom. So I'm really seeing 3 rectangular prisms put together. I know the strategy for solving this is going to be to find the volume of prism A and prism B and prism C, and then we will be adding those together to get the overall volume. Well, let's get started. Let's start up here with prism A. We are looking for the length, the width, and the height because we will be multiplying those things together. I see that there is a length of 6. I see that there is a height of 4 right there. And where are we seeing the width? That's the question that we want to consider. Well, all of them actually have exactly the same width. Because I see, let me get a lighter color here. I see a width of 3 here, and a width of 3 here, and a width of 3 here. That is how I find that width has to actually be 3. So I've listed it over here, even though that is the width. Because again, we can multiply these 3 factors together in any order and find our answer. I see a good basic fact here. If I multiply 4 times 3 and get 12, now I need to multiply that by 6. And I know that 6 times 12 is 72. Now that is just the volume of prism A. And remember, we're going to report that in cubic millimeters. But now I need to come and I need to also find the volume of prism B. And then, of course, we'll do C. Now, which would you expect to be larger, A or B? Well, definitely B is going to be larger, but it's not going to be double because look, the length here is 6 and the continued length over here is 5 more than that, right? So it's not like it's exactly double. That would be if this were 6, just like this is 6, but it is definitely going to be larger. Now, let's go ahead and let's take a look here. I have a length of 6 here. So I know that this portion has a length of 6, but look, there's 5 more millimeters. That tells me that the length is 11, right? I could also figure that here because I have 8 plus this length is 3 more. Again, that tells me that the length is 11 no matter which of those congruent parallel sides I'm looking at. Now I know that that height, of course, is 4, and the width, as we've already said, is going to be 3. So now we're going to be multiplying these things together. I know that I've got 11 times 12. That hopefully is a fact that you have memorized. 11 times 12 is 132. If you don't have that memorized, of course, you could come to the side and do a little scratch work, but you'll find that answer that 11 times 12 is 132. Now we're going to find the volume of prism C. right? Now, prism C, take a look. It has a length of 3, a width of 3, and the height is actually 5 here. So I know I'm using volume equals length times width times height. Here I have length of 3, width of 3, height of 5, right? So 3 times 3 is 9. I'm going to be multiplying that by 5, and I have 45. And again, that's 45 millimeters cubed. Now, we have all the information that we need to get our answer, but we have to add these things together. I've got to add my 72 plus my 132 plus my 45 to find out all together what the volume of those three shapes is going to be. So I'm going to write my 72 over here, my 132, and my 45, keeping it nice and aligned. Let's add the ones places. 2 plus 2 plus 5. That will be 9. 7 plus 3 gives us a 10. 4 more is a 14. Here's my 4. Carry a 1. 1 plus 1 is 2. So now I have my answer. I know that in all, the volume of this shape is going to be 249 millimeters cubed. What a great volume question. Now let's go below and let's take a look at multiplying a whole number by a fraction. I'm going to click the button to get that. There we go. Now we're zoomed a little bit better. Let's take a look here at number 1 for this question. We have 6 times 3 and 1/3. Remember what we've seen time and time again. We are going to be multiplying this 6 by 3 first. 6 times 3 is 18. Oops. And I'm not going to be multiplying these. I'm going to be adding these because the multiplication is happening here. Now I'm going to multiply 6 times 1/3, which gives us 6 thirds. Now, 6 thirds. I know that 3 goes into 6 exactly 2 times. So now I can just join my 18 and my 2, and I have an answer of exactly 20. So the answer to question 1 here is 20. Now let's come up and let's use some similar reasoning for question 2. We have 8 times 9/4. Now here, once again, we're multiplying our 8 times our numerator. So remember, if you're multiplying a whole number times a fraction, you can multiply the whole number times the numerator and keep the denominator the same. So 8 times 9 is 72, and that denominator stays a 4. Now, how many times does 4 go into 72? It goes in exactly 18 times. So we would find that answer if you're unsure by actually dividing. How many times does 4 go into 72? It goes in exactly 18 times. So my answer for this part 2 of this question is 18. We have one more question to consider for this. We have a mixed number. We've got 4 and 32 over 100, 32 hundredths, and we're going to be multiplying that by 5. Now, remember, we can do the same thing that we saw here on question 1, except we're just looking at our whole number right here. So I'm going to multiply my 5 times 4, and that is going to give me 20. Then I'm going to multiply my 5 times 32. So now I have 32 times 5, which actually gives me 160, and my denominator stays the same at 100. Now, how many times does 100 go into 160? It goes in one time, doesn't it? And there are 60 left over out of 100, and we can add that 20 to the front. So now we have an answer of 21 and 60 over 100. So I'm going to go ahead and record that answer here. 21 and 60 over 100. Now, some of us, when we gave that answer, we listed it a little bit differently. Remember that 60 over 100 is the same thing as 21 and 6 tenths. So some of us have listed it like that, and this is just as correct as this one. So we would accept this as correct for that third answer, just like we accept that as correct for the third answer. Because of course we know that those are equivalent fractions, they certainly would sit in the same place as the number line. All right, our next question says complete the cuboid below and determine its volume. So let's get started. Here we see the start of our cuboid. I like to look one face at a time, right? So, for instance, if you'd like to, you could actually do the cuboid over here on this side or this side. But I'm going to go ahead and start with the top first, and I'm going to let that kind of guide the rest of it. So here, I am making one row, two, three, and then over here, it looks like there's one more, even though it's quite shallow. We're going to go ahead and give it one more right there. Now let's go ahead and we've done our rows. Let's go ahead and do our columns. Now, some of these are partitioned off and some of them are not. So we need to be really careful here. We've got 1, 2, 3, 4, and 5. Let's take a look here and see if I've done that correctly. Certainly, the writing on this does make it a little difficult. 1, 2, 3, 4, 5. So this does give us 5 when we look at it this way, 5 cubes, 1, 2, 3, 4, 5. And then here we see 1, 2, 3, 4, 5, 6. So I have not done that correctly. When I look at my key, let me show you how we should have this done. And we'll go ahead and we'll correct this together. Sometimes this happens, boys and girls, especially, I would say, in this one. Normally, the cuboids that we see on these spiral reviews maybe are a little easier to decipher. So if you made a mistake, certainly, mathematicians do. We sometimes make mistakes, but what's important is that we learn from those mistakes and kind of adjust accordingly. And that's what I'm going to do right here with you. Okay? So we did have 5 rows, right? And that is what we're wanting to see here. So let's go ahead and let's divide this out so that we are seeing 5 rows. 1, 2, 3, 4, 5. Okay, we've got that. Now we are going to go ahead and make 5 columns as well. So that is where I made my mistake. And that's okay. Great mathematicians sometimes make mistakes. We just got to adjust. Now I'm seeing 5 rows and 5 columns. So if I were to look at this like an array, there's 25 squares that I'm seeing here, which represent, of course, 25 cubes in this particular layer. Now, what's important as we are completing this is now every time that we're seeing an ending here, we're going to go ahead and mark it off. There's 1, 2, 3, and then this makes the 4th and the 5th, right? Let's go ahead and look at it this way too. We see 1, 2, 3, 4, 5. Okay. Now, this one is correct. Remember, this is our non-example, which happens to all of us. But the reason that that's so important is because we, number one, want to complete the cuboid correctly, but number two, we're determining its volume. So we do want to make sure that we are determining this correctly. We've already said, even just looking at this particular face, we're seeing the 25 cubes. And how many layers of 25 cubes do we have? Well, we only have one. So the answer to this, the volume, is going to be 25 cubic units, right? Or 25 cubes. Now, one more question remains in our Wednesday column, and it actually is our question 5 for our Thursday column too. So that's why I'm going to kind of use the space. If I'd like to, you can feel free to kind of come over here and use this space as well, because this one, your answers can vary. I mean, the way that I make my swimming pool can be very different than yours, but feel free to utilize the space over here. This says, draw a picture of a swimming pool with a cuboid shape, label its dimensions, and a bonus would be to create a design that combines 2 or more cuboids. So would this be following the directions of the bonus? No, because this is one single cuboid. Now, that does not mean that you have to do the bonus, but if so, it's going to be an additional cuboid in addition to, for example, a shape like this. So I don't know about you. I love to spend time at the pool. So I'm going to be designing a pool that has kind of like a shallow end and a deep end where we could do some diving. And that's why my cuboid is going to have kind of some different shapes that come together. I'm going to switch colors just so that, especially since I am going to be going over this dark line, hopefully that'll make it a little easier for you to see what I'm doing with this cuboid. So here is the shallow end of my pool. Okay, it's going to be long and kind of an area where you can come in, you can swim over here before I'm going to make my deep end over here. So first, let's focus on my shallow end. So this is going to be 1, 2, 3, 4, 5, 6, 7. Do you see that I have 7 columns here? 1, 2, 3, 4, 5, 6, 7. So I have 7 columns. Now, here, I'm going to have just 2 rows, right? Now, do remember, we're making this a cuboid. So a cuboid is not just going to show the area like I have so far. It's going to show actually really a three-dimensional shape, right? So here I'm seeing kind of like the sides of my pool. There I see on this face. I now am looking at those 2 that were started here, and then I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, so now I have it there as well. So how many layers does this cuboid have? It really just has 1 layer, right? And I'm seeing that kind of from a side view. Now, my pool is going to have a deeper section here. So it has kind of this lap area almost. But now I'm going to make sure that it also has an area where we can have like some diving boards. We could go into the pool over here. So let's make those rows. I've got 1, 2, 3, 4, 5. Okay, so I'm seeing 5 rows this way. And now let's go ahead and let's make those columns. We've got 1, 2, 3, 4. Notice I'm labeling my dimensions as I go, right? Now this is a cuboid. So am I done? I am not. I need to go ahead and I need to make sure that I'm drawing these sides as well. So I've got 1, 2, 3, and I can actually label that 1 over here. Now I need to have something similar going on this side. So I'm going to do it this way, and I'm going to show that I have got 1, 2. Okay, now that one's kind of hard because, of course, I'm seeing the top of this prism here, and then this one I'm seeing the side. But I have now drawn a swimming pool, and it does have a cuboid shape, and I've labeled the dimensions as I went along, and I did the bonus challenge. Now, if you don't want to do the bonus challenge, you could have just done this cuboid. You could have just done that cuboid, but I put them together to create a swimming pool that is going to have some laps, and then over here, maybe I'll have some little diving boards or something like that. All right, boys and girls, well, that finishes out our